Hello friends, this question is basically related to the part of the arithmetic progression, and over here in this question we are just going to use the concept of the common difference and the general term of an AP. So see, before going to the question, we know that the common difference is what? That is same throughout the series in arithmetic progression, and its general term can be written as AN, that is the last term AN is equals to the first term A1 plus n minus 1 into d. This n is what? Total number of the terms, and d is what? That is the common difference, and an is what? That is the last term, and a1 is what? The first term. So we are just going to use this result over here in this question. So the question says that if a1, a2, a3 up till an are in AP, so we have to find out the value of the given expression over here. So see this expression, and we know that if the radical sign is available in the denominator of the expression, so we have to rationalize it in order to remove or eliminate this radical sign. So see, this general term can be written as an is equals to a1 plus an minus 1 into d. This can be written as an minus a1 is equals to n minus 1 into d. So we are just going to use this result over here. So we have to mark this as equation first. Now the another equation, that is the common difference. So see, we know that is a2 minus a1, that is what? That is simply equals to d, common difference. So a3 minus a2 is again what? That is common difference, and so on. This can be written as an plus 1 minus an. This can be written as, this will be equals to d. So we are just going to use this equation as a standard equation and mark this equation as equation 2 over here. So these are the two equations, and we know that the third equation we have to represent the an plus 1th term. That can be written as simply an summation of the nth term plus the common difference. So we have to use this another equation as a standard equation and mark it as equation 3. Now we are just going to use these three equations while find out the value of this expression. So see this, we have to rationalize the expression in order to find out its value. So this value we have to find out, and we have to rationalize the denominator. So after rationalization, what we get over here? We get that is under root of a1 minus under root of a2 divided by, we get a plus b and a minus b in the denominator. So we have to use the identity, that is a square minus b square in the denominator. So this can be written as a1 minus a2 plus, this can be written as, this term can be written as, this is under root of a2 minus under root of a3 divided by a2 minus a3. Now so on, this term can be written as under root of an minus under root of an plus 1 divided by an minus an plus 1th term will be there. So after the rationalization, we have this expression, and see over here we know that a2 minus a1 is what? D. a3 minus a2, that is d. an plus 1 minus an, that is equals to d. But over here this is what? a1 minus a2, a2 minus a3. So this will be what? D, but of negative sign. So minus d, minus d, minus d, and so on up till minus d. So we are just taking minus d as a common throughout the expression. So minus 1 upon d and the remaining terms inside the bracket, that is under root of a1 minus under root of a2 plus under root of a2 minus under root of a3, and so on. This can be written as this plus sign of under root of an minus under root of an plus 1, that term will be there. Now we see this in this step, we have this under root of a2 will be cancelled out by this plus under root of a2, and minus of under root a3 will be cancelled out by the further term, and in the same way this under root of an will be cancelled out. So the remaining terms are what? Minus 1 upon d into under root of a1 minus this term, that is minus under root of an plus 1th term will be there. Now we have to shift this minus sign inside the bracket. So we get what? 1 by d into under root of an plus 1th term minus under root of a1 will be there. Now this will become our answer, but we have to match our options as given over here. So we have to match our options. So we can write it as, see, we have to again rationalize its numerator by multiplying its conjugate and dividing by its conjugate. So we can write it as an plus 1 plus under root of a1 divided by under root of an plus 1 plus under root of a1. So see, in the numerator a plus b and a minus b term will be there. So we have to use the identity of a square minus b square. So this can be written as 1 upon d, and this can be written as an plus 1th term minus of a1 divided by under root of an plus 1th term plus under root of a1 will be there. Now see, this is an plus 1. We have to use this equation 3 over here. An plus 1 can be written as an plus d. So we are just going to write it as 1 upon d and into this is an plus d minus of a1 divided by under root of this an plus 1th term plus under root of a1 will be there. Now this can be written as, see, we have to use our equation first. An minus a1. This is an minus a1 can be written as n minus 1 into d. So n minus 1 into d, and this plus d will be there. So plus d divided by under root of an plus 1th term plus under root of a1, and we have to multiply it by 1 upon d. So see, this d and d will be taken as common in both the terms, and this d will be cancelled out by this d in the denominator. So this d and d will be cancelled out. So what we get over here, n minus 1 plus 1 in the numerator, and in the denominator, that is an plus 1 plus under root of a1 will be there. a1 will be there. Now we can write it as, see, this can be written as, this will be equals to, over here this is not visible, so we are just going to write it over here in the above steps. This can be written as this, an minus a1 can be written as simply n minus 1 into d, and simply this d will be there, so plus d will be over here, and see, we have the denominator, that is under root of an plus 1th term plus under root of a1, and this is going to be multiplied by d. Then see, this d in both the terms, so we are just taking d as common part. So this d will be cancelled out by this d at the denominator. So we get what, n minus 1 plus 1 will be there. So minus 1 plus 1 will be getting cancelled out. So we get what finally, as a result, n divided by under root of an plus 1 plus under root of a1 will be there. So this will become our answer. So this will be the answer of the given question.